Hi dear students, let's see this question that came in KVPY 2019 SX Part 2 Physics paper. Basically, it's a very easy question, and this mostly is a class illustration of all the teachers like who are teaching for JEE. So I'm sure that any student who is prepared for JEE mains also would have seen this question. It's a very regular question. So let's see what's happening over here. There's a string of length L, which is of uniform density. Okay, uh, and this string is hanging. So there's a transverse wave pulse which is generated at the bottom of the string, and we have to choose the correct options amongst them. Okay, so like the options are whether the speed will be constant or whether the speed will decrease. The time taken by the pulse is going to be proportional to root of the length of the string, and so on and so forth. Okay, so let's first see what is the tension at distance y from the bottom. So if you write the tension at this point, which is like at the distance y from the bottom, so we can say that tension here will be balancing the weight of the string below this. So if you see the this part of the string, so the tension T going up at this point, okay, tension T going up at this point will be balancing the weight of this part. So what is the weight of this part? Mass of this part, which is m by L into y. Let's say that m is the total mass and L is the length. So m by L into y into g. So this is the tension at this point, correct? Now, what is the velocity of the wave at this point? So if any transverse wave is generated at the bottom, so velocity at this point will be tension at this point divided by linear mass density, which is m by L. Okay, so you can see that T by m by L value is nothing but root of y into g. This is the value of velocity. Okay, hence velocity is a function of root y. Okay, velocity is a function of root y. Now let us compare this with a very interesting result. Suppose, let's talk about kinematics. Okay, suppose this is a particle and this is the ground. Okay, and you drop this particle. Okay, you drop this particle. So after falling through a height h, what is the speed of this particle? Can we say that after falling through a height h, speed of this particle is root 2 gh? Right, we all know this. Using the results of kinematics, we can say that after this has fallen through a height h, its speed is root 2 gh, where g is the acceleration due to gravity, or the acceleration with which particle is falling down. Now if you see this result, can we say that these two results are identical? Like you can write this result as 2 into y into g by 2. So it's like after moving up within distance of y, the wave has acquired the speed root gy. So it's like wave is moving up with an acceleration of g by 2. If you compare this result and this result, so you will realize that these are absolutely identical. Here the initial speed is 0, here the initial speed is 0. So wave is moving up with an acceleration of g by 2. Okay, so how much time wave is going to take to travel distance L? So simply we can say that S equals to ut plus half at square. Displacement is L, initial velocity is 0, acceleration is g by 2. Okay, half into g by 2 into t square. Okay, so t is the time if that wave is going to take in going from bottom point to the top point. So we can say that t comes out to be 4 by g into L ka under root. Okay, so this is the time period, time which the wave is going to take from going from bottom to top. ये time आ रहा है. Now if you're going back to the option, the speed of the pulse decreases as it moves up. Of course it is wrong, because we can see that speed is increasing as it is moving up. Time is proportional to root L. Yes, यही आया था हमारा, time root L के proportional है. ठीक है. Tension will be constant along the length. Of course wrong, क्योंकि tension y का function है, linear function है. And speed of the pulse will be constant along the length. Speed is also not constant. In fact, acceleration is constant, not the speed. Okay, so this is how we could have done this question. I hope you would have understood. That's it.